Welcome to our class of chemistry practical within our channel Skills Learning Network. Skills Learning Network, this is a network for education. We are here to stream our session of chemistry practical. So you are welcome again. If this is your first time, you can subscribe to see the experiment number 1 and the introduction of volumetric analysis related to practical of chemistry. My name is Mr. Jawad Maguru. You are welcome. You can learn more here: chemistry practical, physics practical, even biology practical. But for today we are in chemistry session or chemistry practical, and this is experiment number 2 as you see there. So you are provided with the following solution. We are going to see how this question is calculated or solved, and you understand more our lesson. So you are supposed to still here, and you can stop this lesson, you can stop this video to understand more, to take a note, to know how this question have been solved. So this is titration experiment number 2. You have provided with solution sodium hydroxide solution 0.05 molarity, be ethanoic acid or acetic acid of unknown concentration. So according to that, you are supposed to know, you are going to determine the unknown concentration of this one, and the other question can be added. Phenolphthalein indicator is we are going to use. Procedure is very short procedure, so you are supposed to know how to use B, that is acetic acid. You are supposed to put in a burette, and the solution A you are going to use in a conical flask or to be measured by pipette. Then you are supposed to perform titration until the ending point for reaction is reached. So then after performing pilot experiment number 1, experiment number 2, experiment number 3, then we are going to record the results in table or in tabular form. That is very important to note. Then after titration, you are going to meet with the questions. That is our questions you are supposed to know, and you are supposed to note the data above clear. You are supposed to note the data above that is clear. The questions state the volume of pipette used and the burette used. You are supposed to note the readings on that apparatus. The burette is seen 50 mils, and the pipette is almost according to the question you are supposed to use. You will see which pipette have been used. State the color change at the ending point, that is titration end. Finding the average volume of B used or tighter volume after titration, you are supposed to find the average. Question number 4, calculate the number of mole of sodium hydroxide used in titration. Then write the equation for the reaction of sodium hydroxide with the ethanoic acid or acetic acid. Then number 6, calculate the number of moles of ethanoic acid present in 1 liter, that is 1 decimeter cube, that is 1 decimeter cube. Yes. Then another questions, deduce the number of moles of ethanoic acid present in 25 mils or centimeter cube. Then you are going to convert the volume of mole, the value of mole of ethanoic acid calculated in 2 grams of ethanoic acid. That means you are supposed to convert this one, the mole obtained in this one, into mass. That is our questions. And the titration is performed in the following apparatus. In the following apparatus, you can see here in short, we have dropper to transfer indicator. Then we have, that is dropper. We have burette. That is a sample of our burette. Is not very seen, but that is a type of another burette. Another, you can see another apparatus. You can see another is we have pipette. That is our pipette used in our practical. That is a sample of our apparatus, which is pipette. Another apparatus is lithotrity stand to support burette. That is our lithotrity stand. That is our lithotrity stand. That is our lithotrity stand. Another apparatus, you can see that is to descend with the burette. To descend, this is conical flask. That is conical flask. Conical flask with readings. Another conical flask, you can see another is this one. This is conical flask. This is conical flask. Yes, it's very nice. This is conical flask. This is conical flask. Yes. So another apparatus, you can see there is white tile to make sure you observe the color clear, to make visibility of the color. That is a person or expert performing titration. That is titration. So you use it. That is our setup. We have little stand. We have conical flask with the solution. We have white tile, and then that is our experiment preview. Then that is a person perform titration. We have a full set. We have a full set of that one. That is full set of our apparatus. That is a pipette filler. Pipette filler means instead of using mouth to pipette, you can use to fill a booth with that one. That is pipette filler. That is pipette filler. Another apparatus is a dropper. We have seen there previous. That is another type of dropper. That is a person. You can note this one. You're supposed to note perpendicular, not above, not down. So supposed to be perpendicular with your eye. So that is a very important technique or noting the readings. Another apparatus, there is a beaker to support solutions or to put solutions. That is our apparatus. We have beaker and another apparatus we have been observed. So that is our apparatus. So according to our equation, let's see, we go to see the solutions used to solve our questions or our experiment. And we are supposed to write it in that way. That is passing through. That is answers. Pipette used above the table. Burette used above the table is very important to note. Even if you have been asked or not, you are supposed to write. In the table of results, titration, you are supposed to note, make sure there is a units. SI units is very important. In the table of results, you are supposed to consider your value to be in two decimal places of your volume you recorded. The volume of pipette used is 25 according to our equations, and the pipette we have been used in our laboratory. Volume of burette is 50 mils. Even this question you can use 20 mils. Pipette is very important to note the pipette used. What is the color change from the first to the end point? According to our indicator is POP of a north line indicator. The color changed from pink to colorless. So you can see the pinky color. What is the pinky color? Pinky color. Let's see, show you here the pinky color of the solution in base. That is our pinky color. Then in neutral is going to see colorless. So that is our color change. The average volume used is calculated in that way. You can stop to note to understand our calculation as you pass through. And the volume used is 25 also. So that is our answer for that question. Question number 4, the number of mole sodium hydroxide used in titration. Molality, mole per volume. So what is mole of sodium hydroxide? We have molality, we can find the mole. That is our calculations, and we are supposed to conclude in that way. So the chemical equation between sodium hydroxide and ethanoic acid, that is our chemical equations, is very important to write on that way. Make sure you consider yeast state. So here we have, this is aqueous also. This is aqueous solution. This is aqueous solution. This is aqueous solution. So it's very important to note. Molar ratio is 1 to 1. So the number of mole ethanoic acid present in 1 dm That is another question, number 6. Number of mole of ethanoic acid. So mole can be molality. So because ethanoic acid is a known concentration, we are supposed to note what the mole usually, or molalities, that is the molar concentration, is solved by considering the formula which is suitable. So suitable formula according to our question is molar ratio formula. That is our formula as you see there. And the number of mole calculated is that one. Yes, is the same as the base, because the number of mole after balance in chemical equation is 1 to 1. What is the number of mole ethanoic acid present in 25? If in 1 liter was this one, what would be in, what the mole would be in that one, in that 25 mils? Let's see, check our calculations. If 0.05 mole was in 1 liter, how many would it be in 25 mils? So that is our calculations, and then that is our answer for that. So then you are supposed to convert this one into mass of ethanoic acid to know how many mass is dissolved in 1 mole. So that is our answer for that questions. So according to our questions and the questions, according to our experiment and the questions, now we end up here. We will see another experiment number 3. Another time we'll see experiment number 3. So this lesson, if you are appreciated this lesson, let's see you subscribe, then you share to others, your partner, your person, or your fellow, or your friend, to understand this lesson. If it is very good lesson, you can comment through a space of comment there down. Thank you. This is Skills Learning. This is the Skills Learning Network Excellence Learning for excellence understanding. Thank you to listen me.